Okay, so we want to prove this limit without using L'Hopital's rule. So first we should note for positive x, well, it actually doesn't have to be positive for the first statement, but I'm only going to be looking at positive x. E to the x equals 1 plus x squared over 2, etc., etc., etc. So then that would mean if x is positive, then e power x would be bigger than x squared over 2. Or actually, you could just say it's just bigger than the x. But I'll say the x squared over 2 because what I'm going to do now, use a substitution. Let's say x equals root 2x. So then you get e to the root 2x is bigger than, and then this will just be x then. So that's useful. That's useful. Now, also, for x greater than 0, that means log x, x greater than 1. So actually, we might as well keep it consistent and just say x greater than 1. It's still true. Log x will be positive, so that would mean then that log x over x is positive. Now, consider our statement e root 2x, e power root 2x is bigger than x. If we put a log on both sides, that would mean root 2x is bigger than log x. And then if we divide both sides by x, that'll be root 2x over x is bigger than log x over x, which would mean then that log x over x is less than root 2 over x. So if I call this 1 and this 2, so 1 plus 2 gives log x over x is more than 0 and less than root 2 over x. Now, the limit as x goes to infinity, which is certainly more than 1, and the squeeze theorem, that would mean that this gets squeezed between 0 and 0. So that means the limit as x goes to infinity of log x over x is 0, which means the limit as x goes to infinity of minus log x over x is 0, because I just multiply by minus. I can take the minus up on the top, and you get the limit as x goes to infinity of 1 over x times log 1 over x is 0. So therefore, if I just, instead of having x go to infinity, I'll have a different letter like small x go to 0. So therefore, the limit as x goes to 0, but if x is going to positive infinity here, these guys are all positive, so it has to be to the right. X goes to 0 from the right. X log x is 0 then, which is exactly what we needed to prove without L'Hopital's rule.